So as we move forward with Lab Online, all of the information for the lab will be found in the Chem 151L tile. So our first lab is going to be atoms and elements, and that was supposed to be the first lab we did after we came back from spring break. So to find the information that you need, you want to click on the modules link in the Chem 151L tile. So when we click on the modules link, the modules come up, and atoms and elements is the first module there. And we see here that the lab report is due on March 31st at 11:59, and you're going to upload that here. So we'll go over this in this video, but your lab report is, as it's always been, must include the pre-lab questions on page 67, the completed report sheets, which we'll review, and your work doesn't have to be in pen, but I absolutely have to be able to read it. And sometimes pencil can be very hard to read, so if I cannot read an answer, then I'm going to count it as wrong. So if you do use pencil, be sure that it is legible. All right, so let's take a look at this particular lab. If you don't have your lab book, each lab will have a copy of the pages in the lab textbook. So if we click on this link, Atoms and Elements Text, there's another link, and it will bring a PDF up of the pages that were copied. So as always, you want to be sure that you read every single page. There's about 10 pages here to read. It is well worth the time. Not only will it help you understand how the lab connects to what we're learning in class, but also this reading tends to give you answers to the pre-lab questions. So if you've done this reading, it will enable you to answer those pre-lab questions more easily. So here are the pre-lab questions, and the first question is describe the periodic table. Well, that's a really vague question, so to get a sense of what they're looking for here, you can find this answer in the introduction. So all of these questions have to be answered for the lab report, and then now let's take a look at how you're going to fill out the report sheet. So if we look at page 66 of the experimental procedure, let me make that a little larger so we can see it. Part A is physical properties of elements. So that's basically some of the descriptions, some of the observations we can make. So materials are a display of elements. If we were doing this in the lab, there would be jars of various elements throughout the lab that you would pick up and look at. So what we're going to do instead is we have photos of these elements. So you're going to take a look at the photos of these elements, observe them, and then from your observations identify them as a metal, metalloid, or nonmetal. So basically what this exercise is having you do is identify the physical property of luster with metals. So we have a series of elements listed here. We have pictures of all of them. You're going to write the symbol based on the periodic table. Remember to be very careful about capital and lowercase letters. That does make a difference. The atomic number, which again you'll find on the periodic table. The color, and silver is an acceptable color. And luster, whether it has luster or not. So as we learned in chapter 2, all metals should have luster, which is that shininess. If they don't have luster, then what you want to do in parentheses is write the term oxidized, because what that means is the metal has lost some electrons and formed some other compound. So you want to let me know that all metals should have luster, and if they don't, it's because there's been some sort of chemical reaction with usually the oxygen in the atmosphere. And then you want to identify each of these elements as a metal, metalloid, or nonmetal. Now in the laboratory I would give you a periodic table, but you'll be using your periodic table from the textbook, and so that will give you the symbols as well as the the atomic number. You do have to look up the name on the other page because this periodic table doesn't have the name of each element. But one of the advantages of this is it has a color coding of whether elements are metals, they're yellow, metalloids, they're purple, and nonmetals. So you can use your textbook as a resource to answer that part of the questions in Part A. And metalloids will have some less luster. So the only things that should not have luster are the nonmetals, and again, if the metals do not have luster, if they're not shiny, put in parentheses oxidized, because that means the metal has oxidized. Now this part here, B, can sometimes be confusing to people, so remember the directions for this lab report sheet are on a different page. So here on page 66 are the directions for Part B. On the partial periodic table in your report sheet, write the symbols and atomic numbers of the 14 elements you observed in Part A. So you don't have to do every element, you just have to do the 14 elements that you observed in Part A. This is super important. Write the period numbers on the left of side of the table. If you don't do that, you're going to lose points. So the periods are the rows, and they go through 1 through 7. And I'm not sure if they have all 7. It's just a partial periodic table. So just write the periods of what's on that partial periodic table. Outline and label the columns that contain the alkali metals, alkaline earths, halogens, and noble gases. So you can just use an arrow and point to where each of those are on the periodic table. And when you're looking at the alkali metals, be sure not to include hydrogen, because hydrogen's not an alkali metal, even though it's in group 1A. Outline and label the sections that contain the transition metals. And again, you can kind of just put an arrow towards that. And draw a dark heavy line to separate the metals and the nonmetals. So all of these features I'm going to be grading, so make sure you follow these directions and it's clear on your lab report sheet. Do not forget to answer the questions and problems. All of these are going to be graded, and just be really careful. You can do it, but a lot of times there are careless errors. All right, and then Q3, we also have photos for this, and we don't have any chromium in the lab, so we use antimony instead. So you'll see a photo of antimony, and then actually before you look at the photos, you want to have a prediction whether it's shiny or dull based on whether these compounds are metals, metalloids, or nonmetals, and then here you can just identify whether your prediction was correct or not. Okay, part C, you just need a periodic table to answer. You may want to look back in chapter 2 to remind yourself what the mass number is. Remember, you are not going to find the mass number on the periodic table. The mass number is calculated for a specific isotope based on the protons and neutrons. So the mass number you can see here are all whole numbers because the protons and the neutrons have been added together. So you cannot find the mass number on the periodic table. That's something you have to calculate. But the protons, of course, you can, and the electrons you can. We're assuming these are all atoms, so protons and electrons are the same. All right, and then for the last part here, isotopes and atomic mass, what they're having you do here for each isotope, determine the number of protons, neutrons, and electrons, and that's a review of chapter 2. And then they want you to determine the weighted isotopic average of silver. And you can look back in chapter 2, and you can also look in the introduction. There's an introduction that reminds you how to calculate the weighted average if you're given the isotopic mass. Now, one thing I want to point out, I am going to grade on units. So they don't have units of AMU here. You must write down units of AMU. All right, so if you have any questions while you're doing this, just shoot me an email. I will expect an upload of this lab report, and you can just take a picture of it as long as that picture is legible and upload that. If you have a scanner, that would be great, but certainly not everyone has that. So photos will work as long as I can read it. All right, have fun.